So let's talk about the distance and midpoint. Here are two notes you need to take. These are formulas you need to know. The distance formula and the midpoint formula. So what exactly, well, let's add these two to a real life application. Let's say we're traveling from point A to B. Okay, we're traveling in a private jet. At some midpoint, I need to refuel, right? I need to refuel. Now I need to calculate where this midpoint is on coordinates, right? So I can plug it into my system, and my system knows if we fly with autopilot, where to land. But what if I want to travel the full distance from point A to B? Well, now I need to calculate how much fuel I would consume over a distance. So if we have the two given coordinates, we know the distance we need to travel between the 2 points. Now let's see how that looks in mathematics on a coordinate graph, right? So you're given point A and point B, and they ask you to calculate the distance. So I'm not going to rewrite the formula. I'm trying to save time to keep shorter videos. So where do we find x1 and x2? Well, we can assume in this case, this will be my x1, my y1, and I can find my x2, y2. Well, we can just see which alphabetical letter has been denoted towards the point. So this is point A, this is point B, meaning my first group of coordinate pairs, my second group of coordinate pairs. Okay, so let's go insert our values. Now we have x2. x2 is -1. x1, so what am I doing? -3 squared plus. We have y2, which is -2, -2 squared. I have -4 square root plus -4 square root, which then gives me the square root of 32. How did I find that? Well, -4 times -4 is 16, and same goes for the second one. Now I can even break this up further by saying, well, the square root of 32 could be 16 times 2, which I can then even break up further, where we can say 4 times 4 times 2. And then since I have a duplicate of 4, I can move one forward. So that gives me 4 square root 2. Now obviously you can skip these steps. It's just for the video. Okay, so we found the distance between the points, which is 4 square root 2. So the entire distance over here is 4 square root 2. What about the midpoint? Well, to find the midpoint, we just add our x's together and divide by 2. Add my y's together and divide by 2. So let's go. Let's add our x's. So we have 3 plus -1. So it just becomes -1 over 2. And then we have y1, which is 2 minus 2 over 2. Now let's solve. That's going to give me 2 over 2. This one will give me 0 over 2. Therefore, this is 1, 0. So my midpoint is going to be 1, 0. Okay, so the midpoint in my formula is going to be, or the midpoint of my line is going to be 1, 0. I drew my line a little bit off course, but we'll see. I will now skip to Desmos in a little bit. But before we skip over, let's quickly look at something else. Let's look at another concept. What about if you're introduced to a 3-dimensional figure? Now all of a sudden we're working with a z-axis. So now, what if you're given these coordinates? 1, 2, 3, and -2, -4, -6. What if you're given this? And they ask you to find the distance in a 3-dimensional figure. So what do we do now? Well, we follow the same principle where we have the change in x plus the change in y squared plus, can you guess what's going to happen next? The change in z. Because now we're introduced to a z point. So I will label these points. My first point is going to be my x, my second point will be my y, and my third point will be my z. Later, I'll show you guys in another video where we find the z point on an axis. But I would like to introduce that one with complex numbers too. So for now, let's just learn the technique. So let's go insert our values now. While we have the change in x, I will do this one verbally. Let me give these one reference points so you know what I'm talking about. I just want to save time, so I'm going to speed run this one. Hey, what am I doing? Okay, so what is -2 minus 1? That gives me -2 minus 1 is -3 plus y2. Actually, no, let me not skip time. You can spare a few minutes. y2 is -4 minus 2 squared plus -6 minus 3 squared. So we can now say, well, -3, this gives me -3 squared plus -6 squared plus -9 squared. Now, one thing to keep in mind is whenever you have an even exponent, so let's put an x value with an exponent, this answer will always be the absolute value, meaning it will always be positive. Why? Because two negative numbers, when they multiply, they become positive. Okay? So we have 9, -3 times -3, plus 36, -6 times -6, plus 81. So let's add them together. 9 plus 81 is 90. 90 plus 30 is 120. 120 plus 6 is 126. So now we have the square root of 126. So that would be the distance between the 3 points. Okay, so what about the midpoint then? Can you guess what will happen? Well, to find the midpoint, it's going to be simply x1 plus x2 over 2. Oh, I'm out of space. y1 plus y2 over 2, and then z1 plus z2 over 2. Let's go solve this one. 1, 2, 3. Okay, so the coordinates are 1, 2, 3. So I'm just going to say 1 plus 2 plus 3 over 2 over 2 over 2. Then we have plus -2 plus -4 plus -6. So this is to solve my x, my y, and my z. Let's make a little, I'm going to make a little purple note or pink note to say x, y, and z. Okay. So this one gives me -1 over 2. The next one is -2 over 2. And then the final one will be -3 over 2. Now I can simplify these if I really want to. So I can say -0.5, -1, -1.5. So this is the midpoint between 3 points. So earlier we calculated the distance between these points. So let's see if it's true. I'm going to follow a tiny slope. Let's go. So 1 up, 1 right. Okay, so that's 1, 2, 3, 4. So it took me 4 little slopes to get to, I mean, it's one slope, but 4 little jumps to get to this point. So let's follow the same pattern. So if this is truly the midpoint, it needs to take me another 4 little jumps to get to the second point. So 1, 2, 3, 4. There we go. So now we can see the distance between these 2 points. So this area and this area, or distance of the line and this distance of a line, is equal to one another, which is a geometric property, right? And we'll get to that another time. But for now, this is how we show proof that our formula